and say your name and your organization. Back here, Alan.
I'm Alan Fisher with the Tucson Citizen. This question is for Dr. Pike. You mentioned when you were looking at some of the close shots from the MECA optical microscope, particularly the black glassy material, that you felt that showed that material had been weathered. Are you able to determine if that weathering is from wind or from past interaction with water?
Well, yeah, the black glassy material will slowly wear away from the outside, its outside surface, and that can be for a number of causes. It can be just from being jostled around within the wind. It can be because there is water on the surface. Now, when I say water on the surface, that doesn't necessarily mean it has to be at the bottom of an ocean or on a beach. This can be just the merest surface monolayer of water that might come from the ice underneath, and that will slowly work away. We're looking at dust that has been around for up to 4 billion years, and so even the slowest process can wear it right down to this very fine reddish material that we end up with. So it's very difficult to say definitively with the resolution that we have as to what that process is. We hope when we go in with the atomic force microscope that we will get better clues, because we'll be able to look at the individual particles and at the surfaces, and that may give us a better indication of what at the moment is a pretty open question.
Just to be clear, at this point with the optical microscope, we're not able to make that determination of whether it was wind or whether it was water that caused the weathering.
Up to this point, we haven't been able to make a definitive confirmation that water has been involved.
Thank you, Tom. Is there another question here in the audience? Right here. Go ahead.
My name's Deanna Morgan with Fox 11 News. I was wondering, what will it take to find out what that bright surface is, whether it's salt or whether it's ice?
We need to gather a sample of it and put it in our instruments. They're specifically designed for telling us what the material is. The TIGA instrument is very sensitive to even slight amounts of water, and if it's a high concentration of water, then they'll tell us exactly what the fraction of water to soil is, and the MECA instrument will tell us if it's salt. So we have just the right instruments on the surface here to answer those questions.
Thank you, Peter. Go ahead.
I also wanted to know, it was mentioned that there would be, and maybe it was meant to be a joke, but tasting. Will that actually happen?
Well, you could think of the wet chemistry cell as kind of a laboratory tongue, if you like. It's it can taste salt, it can taste acidity, and while it doesn't look like a tongue, it kind of acts like one, and will send us the signals back so that we can make a material just like that, and we can literally taste it.
Thanks, Peter. Another question here? Or let's go to the phone then. Is there a question on the phone?
Yes, my name is Jim King from Times, West Virginia.
Go ahead.
Okay. Would the most common soil, for example, at the Spirit site, be a close approximation to the soil we're seeing at Phoenix due to global wind transport?
Yes, I think that what we're seeing more and more confirmation of is that the soil and the dust that is settling out are really one and the same material when you get down to the individual particle sizes. What we are seeing at this particular site, though, is how the particles have adhered together, how they've clumped up. And that does appear to be more site dependent. So, yes, we're seeing that we probably have at the particle scale a sampling of the whole of Mars in just one microscope slide. The weightings may be a little different depending on what site we're at, but we're seeing indications. For instance, the olivine may not have come from nearby. It may have come from thousands of miles away and have been lofted and brought to mixed up with the more generalized reddish material that we're seeing everywhere.
Thank you. Is there another question online?
Am I online?
Go ahead. Speak up.
This is Dave Perlman at the Chronicle.
Go ahead, Dave.
The question, there's a difficulty here simply between watching it on the screen and listening. But anyway, I'm trying to find out what the significance of those volcanic particles are are the black particles. Maybe somebody could talk a little bit about what kind of evidence that provides as to past environments because of the degradation of the volcanic stuff.
Yeah, the glassy particles are probably what the soil would start from. If we could turn the clock back to when we first had erosion of the volcanic eruptive material, the magma that comes out onto the surface, it would break down into these glassy particles. It would be produced actually directly from the eruption. And we see from far away, from remote sensing, there is a lot of evidence of glassy particles everywhere. But this is the first time that we've actually been able to image them this close up as individual particles. So that is the starting point. We know that Mars has then had these billions of years to weather the material down. And at the same time, new material is being revealed. So you see a continuous process captured at any one point from relatively unweathered material, this glassy material, to this much more weathered, degraded, chemically altered material, which is iron enriched and which forms the majority of the particles that we're looking at.
Thanks, Tom. We have another caller on the phone line. Go ahead, please.
Hi, this is Ann Ryman with the Arizona Republic in Phoenix. I had a question about, you mentioned this is the first time in more than 30 years that you have Martian soil inside scientific instruments. Could you just clarify the difference between what this lander can do and what the rovers did?
Sure. The rovers were specifically designed to study rocks. And in looking at rocks, they could understand the ancient environment in which those rocks formed. And so the rovers were given mobility in order to get to the rocks and remote sensing equipment in order to find the rocks. So their role was to find interesting rocks, go over to them, kind of grind off the outer surface layers, that could be a weathering rind, and then put instruments against the rock and measure their composition and take a microscopic image of them and do some remote sensing with infrared spectrometry. So those are the kind of things they're able to do. The difference with Phoenix is we're able to actually get soil and ices off the surface, and this is a more active, younger surface, and put them into very sophisticated instruments that can modify those materials in a way that we can understand the minerals, the chemicals, and the microscopic shapes and sizes of these particles. So there's quite a bit of difference here. I think the MER rovers are looking at ancient Mars inside of rocks, and we're looking at modern Mars in the soil and the ices.